Good morning, friends. Myself, Dr. Satish Rikame. I am a lecturer in Kekewag Polytechnic, Nasik. Uh, I am going to deliver you the content for the subject mass transfer operation, and the code for the subject is 22609. This subject belongs to chemical engineering, and in this subject, we'll look out the topic name as liquid-liquid extraction. Now, let us see what is actually this liquid-liquid extraction. In this topic, I'll explain the different sketches for the process like extraction and the distillation. However, distillation is another topic, so my focus is totally on the liquid-liquid extraction. The content for this video is like this: extraction process, then type of extraction, and then the difference between extraction and the distillation. If we'll see the concept map for this typical learning objective is nothing but the extraction, then the concept of extraction, again the applications of extraction, and then finally we'll look out the difference between the extraction and the distillation. Now all you know that there are different separation technologies are available. For example, physical separation is there, evaporation is there, distillation is there, extraction is there, then adsorption, crystallization, and membranes. These are the different separation technologies are available in the market and in the educational field, in the technological fields. Now, if we'll see the level of difficulty for the different operation, we'll see that the level is increases toward the membrane separation, and as far as extraction concerned, extraction is just middle of these processes. Physical separation is very easy, and if we think about the distillation, distillation is quite easy as compared to the extraction, because why? Distillation almost give the pure product, and the product which is obtained after extraction again need the further purification by means of distillation. So our learning objective or the key learning from this topic, that means we can identify the different aspects of liquid-liquid extraction. So in that we'll get the answers of different questions like what is extraction, then the difference between extraction and distillation, state the applications of extraction, state the terminology for the use of extraction. So let us see what is extraction actually. It is an unit operation which separates a desired substance when it is mixed with the other substance. The mixture is brought into intimate contact with a solvent in which the substance is of interest is soluble, but the other substances present are insoluble. So extraction uses two immiscible phases. There are phases that do not mix like oil and water. So to separate the substances from one phase into the another. After the extraction, there are two phases which are formed. The first one is the extract phase and the second one is the raffinate phase. Now look at the diagram. The left side diagram showing the mixing and separation for the particular solvent and the solution. First we'll feed the solution to the mixer. Then again appropriate organic solvent will be added into the solution. Both are intimately mixed with each other, and after certain settling the two phases are formed. The first one is the extract denoted by capital E, and the second one is the raffinate denoted by capital R. And in the right portion we have the separating funnel. Here the strong emulsion of NaCl and water is to be break down by using the water. Both are mixed together. After a certain period of time we'll shake it for half an hour, and again we'll try to settle it out for a few hours. After the few hours of extraction, we'll see there are two phases. The first one is the extract phase and the second one is the raffinate phase. In the upper phase, that means the extract phase, we'll see totally NaCl is separated out from the water, and in this way the extraction is to be going on. See how the separating funnel is worked for the extraction. Separating funnel is there, solute in organic phase and solute in aqueous phase. Both the solutes are mixed with each other and allow to settle for half an hour or the time required for the settling. And after a certain period, we'll get the two phases, extract phase and the raffinate phase. Now the difference between the extraction and distillation. See, these are the two operations which are used for the mass transfer operation. Both are the unit operations, distillation and extraction. Distillation or the fractionation is an operation in which the constituents of liquid mixture are separated by using the thermal energy, and in case of extraction, the constituents of liquid mixture are separated by using an insoluble liquid solvent. Distillation utilizes the difference in vapor pressure of different components at the same temperature to effect the separation, and extraction utilizes the difference in solubilities of different components to effect the separation. Relative volatility is used in case of distillation, and for extraction selectivity is used as a measure of degree of separation. In distillation, a new phase is created by addition of heat, and for extraction, a new insoluble liquid phase is created by addition of a solvent to the original mixture. In distillation, mixing and separation of phases are easy and rapid, but for extraction, it is quite hard to mix and harder to separate. Distillation almost gives the pure product, but the product which is obtained after the extraction again need further processing. Distillation requires the thermal energy, and extraction requires the mechanical energy for the shaking. These are the different applications of extraction. It can remove the product and pollutants from dilute aqueous streams, then wash polar, compound or acid base from organic streams. Again, we can separate the heat sensitive product, non-volatile material. Azeotropic and close boiling mixtures can be separated by using the extraction. Again, this is an alternative to high cost distillation. There are several contaminations in wastewater playing important role. So these pollutants can be removed by the extraction. Many kinds of organic compounds such as pesticides, herbicides, phenol, PHC, heterocyclic and aromatic compounds are also included in wastewater treatment, and that these compounds can also be removed by using the extraction. Industrial and agricultural production and people living could be the source of organic wastewater. So these kind of different pollutants can be removed by using the chemical extraction and using the organic solvent as an extractor. Now the last portion of our video, type of extraction. Extraction is a fundamental technique used to isolate one compound from a mixture. So becoming familiar with the theory and correct use are essential to successful completion of many organic experiments. So the three most common type of extractions are liquid-liquid extraction, liquid-solid extraction and acid-base extraction. It is also known as chemically active extraction. The coffee and tea are the well-known example for the both the liquid-solid type, in which a compound, that means the caffeine, is isolated from a solid mixture by using the liquid extraction solvent. So this is the content for our first video for the UO1, which belongs to the mass transfer operation and which belongs to the liquid-liquid extraction. Out of this UO, we can, or the student can be able to understand the type of extraction. Student can be able to differentiate the distillation and extraction. Again, student can well define the extraction. So this is the content for our video. Thank you. Thank you for your patient learning.